Welcome to the DIY Honda Garage channel. The Honda HR-V is equipped with a variety of sensors that monitor vehicle performance and safety. One crucial sensor is the Accelerator Pedal Position (APP) sensor, which translates the position of the accelerator pedal into an electronic signal. This signal is pivotal for the Engine Control Unit (ECU) to manage fuel delivery and engine performance effectively. The Diagnostic Trouble Code (DTC P2121) indicates that the APP sensor A is reporting a value that falls outside its normal operating range. This issue can lead to suboptimal vehicle performance, including incorrect acceleration responses or potential stalling. Understanding and resolving this error is essential to ensure the vehicle operates safely and efficiently. The following troubleshooting steps will guide you through diagnosing and remedying this issue. The DTC P2121 indicates a malfunction in the Accelerator Pedal Position Sensor A, also referenced as the Throttle Position Sensor D. This sensor plays a critical role in converting the mechanical position of the accelerator pedal into electrical signals that the Engine Control Module, ECM, utilizes to control fuel injection and maintain engine performance. The APP sensor is typically mounted near or attached directly to the accelerator pedal assembly inside the vehicle's cabin. When the pedal is pressed, the sensor detects the angle and sends corresponding voltage signals to the ECM. If the voltage is reported outside the expected thresholds, various engine response issues may occur, including a lack of acceleration or unexpected shutoff. Therefore, it's essential for technicians to diagnose and address this issue promptly. Several factors can contribute to the appearance of DTC P2121. One possible cause is poor electrical connections or loose terminals at either the APP sensor or the PCM, which can interrupt the signal transmission and lead to incorrect voltage readings. Additionally, open or shorted wires in the circuit can prevent the APP sensor from operating within its designated range. A faulty APP sensor itself may also present erroneous signals, thereby causing this DTC to trigger. Lastly, a malfunctioning powertrain control module, PCM, could incorrectly interpret or manage the data received from the APP sensor, resulting in performance issues. Identifying the root cause is crucial for effective repair. When experiencing issues related to DTC P2121, various symptoms may be noticed by the driver. A common indication is an unresponsive accelerator pedal, where pressing down does not prompt the expected increase in speed or power. This erratic performance can lead to difficulties in vehicle operation and potentially dangerous situations if the vehicle does not respond when needed. Additionally, the check engine light will likely illuminate on the dashboard, signaling that a fault has been detected by the vehicle's onboard diagnostics. Alongside these symptoms, drivers may also notice intermittent or unexpected engine behavior, such as stalling or lack of acceleration, which further confirms the need for immediate diagnosis and resolution. In the first troubleshooting step for DTC P2121, it is essential to ensure that the vehicle is in the on mode, activating the electrical systems necessary for diagnostic testing. Utilizing a Honda Diagnostic System HDS scanner, check the voltage values for APP sensor A. The expected values are to be compared against predefined thresholds. Specifically, a reading below 0.32 V indicates a potential failure. If the current condition matches this threshold, the failure is confirmed, and you should proceed to the next diagnostic step. Conversely, if the readings do not match, Further investigation is necessary to determine if the system is momentarily functioning normally, potentially indicating an intermittent issue. For the second troubleshooting step, if the APP sensor A voltage values do not meet the threshold from the previous check, it is vital to look for values exceeding 4.91 volts. If this scenario occurs, it also confirms the failure. However, it suggests a different fault condition. If the values align, the system may currently be operating without issue, leading to a probable intermittent failure. In this case, careful inspection of the electrical connections and terminals at the APP sensor and the PCM is necessary. Adequate attention must be given to moisture or corrosion that can lead to poor connection integrity, as well as ensuring that terminal fittings are secure. The third testing step involves disconnecting the APP sensor 6P connector following the vehicle being turned off. This will isolate the sensor from the vehicle's electrical system for accurate measurements. Next, switch the vehicle to on mode and measure the voltage between specific test points on the APP sensor's connector. It is crucial to obtain about 5.0 V, which indicates healthy voltage supply to the sensor. If the voltage is as expected, the test suggests that the power supply is intact, and it indicates that further troubleshooting in subsequent steps is needed. If voltage is not as required, the possibility of an open circuit in the VCC4 line must be explored. In this fourth step, you will need to configure the HDS to jump the SCS line and maintain this for more than 1 minute to reset the system. Once this is done, disconnect the PCM connector A51P to isolate it for testing. The next action is to verify for continuity between the relevant test points on the APP sensor and the body ground. Achieving continuity confirms that the APS1 wire isn't shorted between the APP sensor and the PCM. If continuity is detected, repair any short circuits in the APS1 wiring. If there's no continuity, further investigation on the wiring integrity and connections is needed to determine the fault areas and ensure proper signal transmission. During the fifth step, the next procedure involves connecting the APP sensor 6P connector's terminal A to terminal B using a jumper wire for testing purposes. This will allow you to check the continuity between the specified test points, which include the PCM connector A. This test helps confirm if the APS1 wire is intact and functional. Finding continuity means that there are no issues with the APS1 wire, allowing you to move forward in the diagnostic process. Conversely, if continuity is absent, it indicates an open circuit along the wiring, which necessitates repairing or replacing the wire between the PCM and the APP sensor to restore normal operation. In the sixth troubleshooting step, after removing the jumper wire, it is essential to reconnect the PCM connector back into place and re-establish electrical communication. Next, create a jumper connection between two specific terminals of the APP sensor connector and set the vehicle to the on mode. Utilize the HDS to check for APP sensor A values again and ensure they are below 0.32 volts as expected. If this condition is met, authorized service information should be explored for the DTCs or relevant operational symptoms for further diagnostics. In circumstances where the voltage does not meet expectations, replacing the entire accelerator pedal module becomes necessary to resolve the DTC effectively. The seventh troubleshooting step primarily focuses on verifying the VCC4 line's integrity. With the vehicle switched off, you will need to start by jumping the SCS line in HDS again, and then disconnect the PCM connector A, 51P. Following this, connect the specified terminals of the APP sensor to body ground using jumper wires. This process facilitates testing continuity between the test points to ensure that the VCC4 wire is operational and intact. If continuity is detected, proceed to explore any necessary service information or consider replacing the PCM. However, if no continuity is found, it indicates an open circuit in the VCC4 wire, necessitating repairs before the system can operate correctly. For this 8th step, the focus shifts back to the APP sensor connector, following the same initial disconnect process. Afterwards, turn the vehicle's electrical systems to the on mode and check for adequate voltage between the specific terminals of the APP sensor. A reading of approximately 5.0 V confirms that the APP sensor is functioning within the expected parameters. If this voltage is detected, it strongly suggests that the accelerator pedal module requires replacement to restore proper functionality. Conversely, if voltage readings do not meet expectations, further investigational measures should be employed to identify the underlying issues affecting the sensor's performance. The final troubleshooting step revolves around checking the SG4 line to ascertain its condition. First, ensure the vehicle is turned off to maintain safety during testing. Repeat the SCS short procedure with HDS and disconnect the PCM connector A, 51P, again. Utilizing jumper wires on the APP sensor, check continuity between the terminals leading to the body ground. Detecting continuity here indicates that the SG4 wire is functioning properly, and you can proceed to refer to any authorized service information for additional guidance. If continuity does not exist, it signals an open circuit, requiring immediate repairs to restore the signal transmission back to normal functionality. Once repairs are completed, to address DTC P2121, it is crucial to conduct a thorough verification process. Begin by rechecking all connections to ensure they are secured and free from corrosion or moisture ingress. Utilize the HDS to confirm that DTC P2121 has been cleared from the system. Following this, it is advisable to conduct a brief on-road test to monitor the vehicle's performance and confirm that there are no lingering symptoms related to the accelerator pedal function. Ensuring that the vehicle behaves as expected signals successful repair. Documentation of repairs and results is essential for future reference. To prevent the recurrence of DTC P2121 or related issues, several proactive measures can be implemented. Regular inspection of electrical connections to the APP sensor and the PCM is vital, particularly noting any signs of wear or corrosion. Additionally, it is crucial to use high-quality components whenever servicing this area to ensure longevity and performance reliability. Performing software updates for the PCM, when available, can also safeguard against programming errors that might cause miscommunication between the modules. Maintaining the vehicle according to manufacturer recommendations will contribute to the overall health of its electrical systems. In conclusion, diagnosing and troubleshooting DTC P2121 involves a structured approach that effectively identifies and addresses the underlying issues with the APP sensor A. Each troubleshooting step provides critical insights into the electrical integrity and operational status of the sensor and its connections. It is vital to confirm successful repairs through verification checks, ensuring the vehicle operates in optimal condition post-repair. Implementing regular maintenance and preventive measures will aid in averting future recurrence of similar DTCs. By paying careful attention to the electronic control systems, vehicle performance can be maintained at its peak, ensuring safety and reliability on the road. Please like and subscribe to the channel. See you next time.